Hello friends, welcome to my channel Physics with Rakshit. In the present video, I will describe various points of discrepancy between Newtonian formulation, Lagrangian formulation and Hamiltonian formulation. And by the end of video, viewers can understand that why Hamiltonian formulation is widely used in modern physics. Each branch has its advantage in physics, and each formulation study different branches of physics. And one should note that Newtonian formulation, Lagrangian and Hamiltonian formulation are equivalent to each other with different mathematical language and with different mathematical tools. Let's understand these three formulations by comparison. So first point of discrepancy is in Newtonian formulation, first, second and third laws of Newtonian mechanics are used to study motion of object. As we all know, first law of Newtonian mechanics tells us that every physical body tends to have tendency to remain in the state of rest or in the constant velocity until external force applied on it. This law is also known as law of inertia, while second law tells us that rate of change of momentum is proportional to force applied on it, and which is in the direction of force. Third law of Newtonian mechanics is for every action there is an equal and opposite reaction. Using these three laws, one can study motion of physical object in classical mechanics. Similar to Newtonian mechanics, in Lagrangian formulation, one can study motion of physical object, but without mathematical limitation, which is in Newtonian formulation. Lagrangian formulation is the alternate version of Newtonian formulation, which is equivalent to Newtonian formulation, which also study motion of various objects. Similar to Lagrangian formulation, Hamiltonian formulation is the generalized version or foundation version of Lagrangian formulation, which is widely used in modern physics because of its advantage over Lagrangian formulation as well as Newtonian formulation. Second point of discrepancy is Newtonian formulation involves second order differential equation which describes motion and nature of motion, while in Lagrangian formulation it also involves second order differential equation which also describes various motion and nature of motion, while Hamiltonian formulation involves first order differential equation which is easy to deal with comparison to second order differential equation. So this is the first merit of Hamiltonian formulation over Newtonian formulation as well as Lagrangian formulation. Next point of discrepancy is in Newtonian formulation, applied forces acting on system is resulted into accelerate the system is concerned in Newtonian mechanics, while in Lagrangian formulation kinetic energy and potential energy are considered. Similar to Lagrangian, in Hamiltonian also kinetic energy and potential energy are concerned. Next point of discrepancy is in Newtonian formulation vector quantities are involved, which is difficult to deal with while studying its mathematics and defining motion, while Lagrangian formulation involves kinetic energy and potential energy which are scalar quantity, and we know that comparison to vector quantity, scalar quantity mathematics is easy, and that is why Lagrangian formulation has more advantage over Newtonian formulation. Similar to Lagrangian formulation, Hamiltonian also involves scalar quantity like kinetic energy and potential energy. Next point of discrepancy is Newtonian formulation doesn't involve generalized coordinate, and that is why one cannot study non-mechanical system using Newtonian mechanics, while Lagrangian formulation use generalized coordinate, and that is why it can describe mechanical as well as non-mechanical system. Similar to Lagrangian, in Hamiltonian also, up to some extent, generalized coordinates are used, and that is why it can study mechanical as well as non-mechanical system. Next point of discrepancy is, in Newtonian formulation, no scalar function is defined, while in Lagrangian formulation, scalar function L is equal to L of Qi dot T is defined on configuration space. It means Lagrangian is a function of position, velocity and time, Qi dot and T. Here configuration space is a kind of mathematical space which is used to study Lagrangian formulation. Similar to L, in Hamiltonian formulation, H is equal to H of Qi Pi T is defined on phase space. It means Hamiltonian is a function of position Qi, momentum Pi and time T. Here one should note that Qi and Qj dot are dependent variable, which is the one of the limitation of Lagrangian formulation over Hamiltonian formulation, while in Hamiltonian formulation Qi and Pi or Qj and Pj are independent variables. That is why it has wide application in modern physics. Equation of Newtonian formulation is, which is more famous, is F is equal to dp over dt is equal to ma, which is the second law of Newtonian mechanics. While equation of Lagrangian formulation is d over dt in bracket dl over dqj dot bracket close minus dl over del qj is equal to 0. This is the equation of Lagrangian formulation for any kind of motion. Similar to Lagrangian, in Hamiltonian there are two equations. First one is qk dot is equal to del h or del pk comma minus pk dot is equal to del h over del qk. These equations are known as canonical equation of Hamilton's formulation. Next point of discrepancy is product of qi and qi dot in Lagrangian formulation is not giving us dimension of action. This is the another limitation of Lagrangian over Hamiltonian, while in Hamiltonian formulation product of pi and qi is giving us dimension of system of action. As we all know, in physics, action means how any physical system changes over time, and that is why to define various kind of action in modern physics, in quantum gravity, in quantum field theory, in quantum mechanics, Hamiltonian formulation is widely used. So next point is application. So Hamiltonian formulation is widely used to study while making transition from classical mechanics to quantum mechanics. It is also, as I told, used to study motions in quantum gravity theory, quantum field theory, quantum mechanics, etc., as it involves study of physical action with independent variables. While Lagrangian along with Hamiltonian and variational principle is used to study diverse field like study of Schrodinger equation. Similar to both formulation, Newtonian mechanics is widely used to study motion of physical object in classical mechanics without considering scalar functions. Another noticing thing is that Hamilton's principle is defined using Lagrangian L, which tells us that of all possible paths, the dynamical system that goes from one point to another point will choose a path where time integral of Lagrangian function is extremum, that is j is equal to integration from t1 to t2 L dt. This principle, integral principle, is widely used in quantum field theory and quantum gravity theory to describe various phenomena. That is why Hamiltonian formulation have many advantages over Lagrangian formulation, and Hamiltonian is widely used in modern physics. So in the present video we have seen that why Newtonian mechanics has certain limitations and why Lagrangian formulation is more useful than Newtonian mechanics, and why Hamiltonian formulation is more useful than Lagrangian mechanics or Lagrangian formulation. Using Lagrangian and Hamiltonian formulation, one can study various concepts of modern physics, such as physical action, which involves various phenomena like Hilbert action, Hamiltonian action, Palatini action, Astakar action in quantum gravity theory, etc. One can easily explain all this action by considering Hamiltonian formulation. So in the present video I have compared three formulations with each other, that is Newtonian formulation, Lagrangian formulation and Hamiltonian formulation. Thanks for listening and watching. If you have any question regarding these three formulations, you can ask in the comment section. If you like my video, please share and subscribe my channel. Thank you very much.